Okay, where this works is when you make code and let's say you're working at Microsoft and you're working on the next release of Microsoft Word, and you're responsible for the drop-down menus on a couple of the icons over here. So they give you a chunk of code to work on, and you work on that code. Well, you don't compile that entire monster every time you make a little change. You put it into a make file, and it has all these .o files, all these pieces of code that other people have worked on, and it assembles it into one giant executable that gets shipped out or downloaded. Okay, that's why we use make files. Makes them simple. Okay, and the way this works is that you have a command called make, and then there's a file called makefile with an uppercase M. And the makefile has a special format on how it works. Okay, and let me bring up a makefile that is rather gnarly looking, if I can remember where it is. Is it here or is it under root? I think it's under root. No, it's there. For this box, I actually compiled Python from source code. And this is the makefile for compiling Python. It has 2,000 lines. That is a very complex makefile. We're not going to do that. Okay. This is how it builds it. So when you can download the source code, the makefile, it's got a lot of brains in it. And it says, hey, what architecture are you on? Let's compile it for Windows, or let's compile it for a 32-bit Linux or 64-bit Linux. Is it ARM or not? So there's a lot to the makefile. What we are going to do is very, very simple. Whoops. Do you see that in the back? Yes, no? No? Okay. Make it bigger. All right. This is a very simple one. So what this does is it will take the source code. It's all in the same directory. So I have my source code and the makefile in the same directory. When you use Visual Studio Code and you start a new project, it creates a directory structure for you to handle all this. Okay. So what this does is when I say make all, it will compile the hello program and go through and do this. And I can type in make clean, and what it does is it removes the object file. So let's show you how this works. So that's the make file. So if I type in make and just hit enter, it's giving me an error. It's saying, hey, I can't do this for right now. Okay, nothing to be done. So let's say make hello. It says it's up to date. It looks at your date timestamp of your file. So if you make a change, let's say you've got a bunch of source code a bunch of source files, and you make a change to 2 or 3 of them, it doesn't recompile the whole thing. It will only recompile and link what's changed. Okay. So let's simply look at the hello C here. And I'm just going to say, hello world, and just add another explanation point and put in another carriage term. So now when I do make hello, it sees that there was a change and it compiled it. And it's telling me what it's doing. So it's compiling it and it created my output. So now I can type in /hello. Hello world. That's it. Okay. So hands-on exercises. Do this. Find some of your source code, the hello world, something simple, and create a make file. And then you can use the links if you want to get more gnarly. And as we move further in and we start doing the GCC stuff and the GDB and the compile and looking at things, we're going to learn about GS tabs, and we're going to learn about the no rewind, no pi stuff. When we take our C and turn it into assembler, we're going to remove some of this stuff to make it simpler to read. Okay. And I'll also introduce the MASM format. Okay. So here's an example of how it works. So here's the make file. So if you say make my prog, it will do this and then follow these steps to make it happen. Okay. And here's the listing. So this is just from the lab. So we want to use a very simple one. So the make file, this is all we have, something simple. So go ahead and create a make file and do this. Have some fun with it. And obviously you will need the hello world program, which we've done already, or use the exit one. Doesn't matter. But basically you can look at your history and see the commands you've been typing in and borrow some of those for your make file. Okay. When you run make, it looks for the make file in the current working directory. That piece of information will save you hours of headache. While you're doing that, I'm going to look at something. Now you can use the editor from the Jupyter Lab, or you can use VI. The editor from Jupyter Lab is probably going to be a little easier. But then once you get it, all you need is your C source code, and everything else will be generated. Okay. That's all we got here. Pretty simple. And then you can run your make file, make hello, and it says make. And if I do an ls here, I see the hello dash o. And if I say make clean, what happens is it removed that file and it's gone. Okay. I've got some other fun files in here too. All right, so see, make file. That's what we're working on right this second. Now, I think what I'll do is just add argv, argc to this. Is I'm going to give you some code right now to write. And this code is very simple. It just takes the integer and it's going to kick it out. That's all it's going to do, very simply. And we are going to modify it in class to use argv and argc, so you know what argv and argc is. Okay. Since I don't think anybody last time I asked who has done argv argc, pretty much nobody. What? Because we don't get a chance to do that in online stuff. All right, so let's do that. Could probably rename some of this. This is the code I want you to type in. Okay. So what this is actually going to do is it just enters an integer, it scans it to see what it is, and then it says your number is, and then after foo add 8. This is going back to our first assignment where we had the main and the foo.c and the foo.h. We'll be weaving this into that. Okay. And you can call it main.c if you want. Call it homework, whatever. Our GCC line, and we can use that for our make file. So we can create a make file for this to make it simple. How many typed in those, the foo.c and foo.h? We got that all done already. Should be everybody. That was one of the first things I gave. All got it? All right. Oops, too many. Oops. I've got the wrong one. I want that one. Bad comment in the code. Shame on me. It needs the HW2 there for homework 2. Now when I copy it, it'll work. And then if I run enter, I put in 5 and foo puts in 8 and gives me 5 plus 8 is 13. This should all be working from the code that you've created already. You should have a foo.c and a foo.h and your main.c. Those should all work. And all I've done is modified the main.c or the main file here to add a few things. Give me an integer and then run it to foo and add it. Okay, can everybody follow the logic on the code? Pretty much, it's pretty straightforward. Declaring our integer, we're telling the user to put it in, and we're verifying that it's an integer, and the number is decimal. After that, add it, display it, and it goes to foo, passes what you put in, and brings back by way of the name foo 13. Okay, so y gets sent, and that's how a function works. Okay, so once we get this working, we will do some modifications to use argv-argc, and I'll talk about those in a second. Let's get this working. We'll have to have consensus. Let's make it work. If you need help, holler. Yes. Pardon? I was a few minutes late. Oh, hopefully, make file, we can do it a couple ways. For this particular piece of code, we can take this compiler line right here. All right, and there's always 10 right answers. And let's do build foo. Do foo. That's all I need. That's it. Very simple. I can make it very simple to do that. And I cannot remember if it's tab delimited or not. I say make build foo. Oops, missing separator line 3. Missing separator. I'm having a fat finger day. Let's use it, let's make it more like the one we've been kind of, we'll call it we'll call this main. Lowercase. And then I want to say I should say names. Internal. I don't think I'm doing this right. Hold on a second. Oh. No rule for target. That means I need I'm gonna have to work on this one because I've got the complexity of adding two to it. I'll have to go look at my let's see. Oh my God. Oh, this line needs to go. Now let's see if this, I should get some nice errors. This seems so weird.
Oh, I got that too. You have to use tabs, not space.
That's right. Okay, everybody. Remember tabs? And in my VI session, my VI session is optimized for Python. And does Python take tabs? No. When you code in Python, you press a tab key, it puts in 4 spaces. That's inside idle, and that's a default. So what I'll go show you what I've got here. Vim on .vimrc. Tabs to spaces. This is what this does. So I need to disable that and say, hey, I want the real thing. So for the sake of argument, I'm just going to move that. To spaces. So I don't now have none. I don't have a vimrc file. But now when I type it, I can actually use a tab. And to see that, notice how the colors change. And there's, let's see if this makes it. Make, and it says, okay, all right, we're getting there. That gives me the out. I need my foo in here. Yep. Foo.c needs to be compiled to. I'll get this figured out eventually. All right, we'll come back to the make file. Let's get it to work. And then I will give you the notes. So when you compile it, that should work. And then you put in any integer and it will add 8 to it, and it gives you a total of 16. Okay. The goal I want to move you to is argv, argc. Okay. And then we'll come back to the makefile. I'll get that fixed and show you what the makefile should look like. Okay. All right. Now, argv, argc, what is it and why do you care? Is if I type in a command like calendar, it only gives me 1 month. But if I have that same command and I pass it another parameter, a 3, it gives me 3 months. Or I can put in a year and it gives me the full year. The way this is working is that this information from the command line after the command is being passed to the program by way of argc and argv. They are basically a character pointer and a vector, and it takes the data and it looks at it, and then your program will do whatever the flag is. In the early, well, you could probably still do this. If I type in view, it brings up them in read only. So I can't make any changes to an existing file. But if I bring up them and the name of the file, let's just do that. Call it junk. Hello. So now if I bring up view, read only, I cannot change it. It's the same program. It's the same chunk of code. The only difference is that when I call the program, it's either called vim or view. That's basically arg0, the name of the program. So there are convoluted C source codes out there that do amazing things. One of them is called BusyBox. Anybody heard of that? BusyBox is a single executable that has a gazillion commands built into it. One, basically, it's your bash shell smashed into one executable. So that's what we're doing here. Okay, argv and argc. So what we're doing now is that I will show you how to convert what we just did here, this enter thing. So if I put in, it's still going to ask for the integer, isn't it? And it's still going to do that. But what if I want to pass the integer on the command line? That's what argv and argc does. Every programming language has this capability. Okay. Everything I've touched anyway. There may be some obscure ones out there. Okay. And let's see here. Let's do. Let's see if this is close. Nope, that's not it. I know what we can do. Here we go. Let's look at this. This is basically the answer. To use argv and argc, we need to include another library. Okay. And we'll use the same compile line and do the same thing. But basically what we're doing is we are double checking to make sure that our counter for the number of commands on the line is going to be, okay, if it's not equal to 2, give me an error. If it's 1, in other words, so I just type in the name of the program. In this case, it's going to be enter 1. It's going to give me an error. If I put in enter 1, 5, 6, and 7, it's going to give me an error. If I say enter 1 and a single character, 8, it will run. So this is saying, hey, you blew it. Go back and do it right. Tell the user how to use it. Then this is a convention that it's usually in, companies have some sort of a usage. So when the user types in something wrong, it's not just a blank screen. They know what to do. Okay. All right. And then let me show you how this works. So I'm simply going to take this whole thing here, and we'll make a make file for this too. If I run enter one and say nothing, it gives me an error. And that error is because I do not have two values. The name of the program is considered a value. If I put in, ta-da, it worked. If I put in, all right, I see lots of blank stares because you don't work at the command line all the time, or hardly at all. This is the kind of thing you, if your program can snarf command line elements, you can do a lot of trippy things. Okay. So let's look at how this works again. Okay. So we are modifying main to use argc and argv. And the asterisk means it's a pointer. We'll kind of skip over that. And then it says, if the argument count argc is not equal to 2, tell the user they made a mistake. Exit. Return 1. It's not returning 0. It's returning 1, saying there's an error. Other code, like if you work at any of the big companies or any company, they will have a set of return codes that are expected based on certain error types. So based on an error type, you'll get a return code that you go look up to say, oops, I forgot something. And you got to go put it in your code. Okay. And then we're checking it here. If it does match, then this is what it's doing. This ATOI is why we need standard lib. ATOI is ASCII to integer. It's obscure, and I would give this homework when I was doing C++ in the classroom. I said, go look it up. And they would go look it up and spend an hour or two on Stack Exchange to figure out how to do this and make it work. And in this class, I just give it to you. So you will know that you can write code, put a value on the command line after the code name or after your program name, and it will process it accordingly. Okay. So, and we're doing the same stuff that we've already done with the foo-h, the foo-c, and your main C. All right, let me put it there so you can take pictures or whatever you need to do. I don't know if you use your phone from that far back, if you could actually get it to come in focus.
I got
Yeah, and then with we'll work on the make files. We'll get that figured out too. I move the code up and down a little bit.
Yeah.
Okay. Your begin working, kind of, sort of,
I got it working.
a little bit working. Okay, help your neighbors around you.
You scroll back down.
Oh, sure.
My addition is working, correct? Did you try to use that?
Hmm?
Uh,
Oh,
It's still using food. So food, you're passing your y, which is the ATY, or are you buffer. You're gonna pass that in the as long as this is Y, you just say Y. Inside of that, it's, what did you get there?
Yeah, it was the last one we used for the food on C, we used +5. I realized
Oh.
that too.
Oh, but I thought it was working. Maybe it was wrong, the other way.
I didn't realize it was +5 either.
Oh, all right, thanks.
We got it? Close enough? All right. Where we're moving next is, this is something that I want you to play with in the debugger by handing off both through both pieces of code with the scanf and also the argv argc. So we'll make sure that it's all posted up on the homework. And the next thing for our homework and our hands-on for you to do this next week is the following. Did I put it in here or not? I have not put it in here yet. Okay, I will do that tonight after the computer science meeting. What we'll be doing is this. In our labs, I'll have pointers to all this stuff. Is in 273, it's a little hard to see, ebooks, chapter 10 .pdf. This is one chapter out of this book. Okay. This book is online in that same location in this 273 labs and links. It is this one, computer.org EPUB. So the entire book is here. This is also in Canvas. It downloads much faster than off my little tired website. And chapter 10 is the one that we will be walking through here. If I can find it. Let's go back. Nope. All right, let's just go back. Chapter 10. Here it is. All right. What you'll be doing.
You said it was a 273 ebook, or was it ebooks?
Chapter 10. Ebooks
Uh-huh.
C10.pdf.
Okay.
And it's this comes up. So ebooks, well, 273 ebooks, chapter 10 PDF. I broke it apart by one chapter just to make it a little bit easier to download so you can look through it. But your goal is to walk through this entire chapter. And here's what you're going to learn. In this chapter, he brings out a few things we've touched on that we haven't really figured out. For example, we can use the -S flag to generate assembler. And then I get my assembler code and I try to assemble it and link it, it doesn't work. Well, why? This chapter will walk you through some of what those whys are. Okay. So as we walk through this, and he gives you a program that is actually very simple, and he's changing the flags to some extent. Let me make, oh, that didn't help. I want to make it bigger. All right, I guess I have to do the zoom thing. Will that work? Kind of works. Okay. A little hard to see. Can you see that line right there?
Yeah.
Down at the bottom. It says GCC wall 00, like what we've been using, MASM Intel. What this is doing is it's changing it from the gas syntax into the Intel syntax. And when you look at the two, big Indian, little Indian, however you want to look at it, I personally think the Intel syntax is a little bit easier. There's not so many % signs everywhere. It's just less noisy. Does it make it any easier to understand? Well, it's how your operators work, the way it's represented. Okay. And what this is doing is that this is actually translate the source code, and it does something interesting for you. So I want you to see what the -E on your C source code to create an I file. What is the I file representing? What's in there? Okay, so this is part of your exploratory game here, because if you just walk through, do these steps, it's pretty straightforward. It's not terribly difficult. And he talks about linking, what they're all about. And then here's your piece of code, we kind of did something like this. We did something very similar. Return 0, main void, nothing. You notice there's no standard library. There's no stdio in here. That makes it even smaller. Okay, so we didn't bring in any library. And this means we have to type in that echo, whatever, to see it. A minimal C program. Okay. And then he explains what these options do. Okay. And he walks through them all and talking about directives. And then notice this next one here. No asynchronous unwind tables. What on earth does that mean? What he's doing is that as he goes through this chapter, he is showing you how to remove some of the advanced feature sets that we are not going to need for our simple little program. So in the Intel chipset, it can do everything except laundry, but we need to turn off some of that stuff to be able to get a cleaner idea of what the assembler really is going to do. Okay, so he walks through this one, and then it shows you what the listing is, and then he keeps talking about it, and then there's this control flow enforcement technologies. Anybody heard of what is it, Spectre bug in the chip? We have to disable the guard that would keep Spectre at bay. So we're saying, okay, let's make our chip dumb again and not use this control flow enforcement technology. So second half of 2020, okay? And I don't know if AMD has it yet.
If you even want to go further back, you can disable the stack smashing protection. Said you could also disable stack smashing.
Yes, yes, stack smashing, yes, yes.
Doing it out of the box as mitigation. They're doing it out of the box as mitigation because the performance hit was so great. AMD has their own version of it now. All this stuff that used to be every thought went away, it's back again.
Yeah, yeah, they gotta go deeper and deeper and deeper into the hardware to make it secure. Okay.
What is it? There's a government organ. I think it's not CERN, but it's basically the government mouthpiece for tech stuff. Do you remember when they said everyone disabled Java? I forgot the name of the company. It started with a C, but they said that the official government stands for IT, Hartley, Spectre, all the other garbage. Was you're not important. What do you care?
CISA.
Yeah.
That might have been that. Yeah, they were saying it was basically they said your machine's so garbage, even if they do have it, what are they gonna get off of it? The cat picture. That was literally what the government was telling. They said they don't care.
They do.
All right. So as we're moving along here, notice FCF protection equals none. Run it again. And then you get an assembly language file that has even less stuff in it. You can kind of see the progression of what we're doing here. We're turning off advanced feature sets, okay? And then he says, I don't know why there's ident section in there. It's probably because GCC had bugs. And then he goes through and says, this is what we're going to do to create the world's simplest basic program here. Creating a program in assembly language. This is the equivalent of our C program written in assembler without all that extra stuff in there. So this is what we would call hand-rolled assembler. So you'll type that in, you'll play with it, experiment with it, okay? And notice it's saying Intel syntax. Notice the differences. If we look at the gas syntax, which he does later in the chapter, these are rotated. Okay. And then he talks about how it works, how to do it when he's explaining about comments. That's, I'll let your boss tell you about that. And he's got a lot of extra points and different, okay. And talks about how the moves work. You use a lot of moves and double word, triple word, how you push and pop onto a stack. Very familiar with stacks. Think of a set of plates in your cafeteria. You push stuff down on a stack and you want to get to the bottom plate. Well, guess what? You got to pop everything off the stack to get to your bottom plate. That's how this works. It's a stack-based idea. And stacks are very simple to implement. That's why they use them. Okay. And processing a function. And then he goes on how it's doing, push and pull. And this is, I think, 26 pages or so. Then, boom, we get into our debugger. Okay. So what we did last week, remember the debugger, and we played around with it and poked around, letter L. We did a little bit of the Python debugger. It looks a lot the same. Get to walk through this one more time. And he's explaining how to compile it for his ways. There's always different ways. And then he jumps right into using the TUI. That's right where we stopped. We said TUI enable, and we showed the nice pretty GUI. The TUI enable will work on the Jeremy box if you're SSH'd in, or if you're using the terminal from the Jupyter lab. You do not need X windows. It is a TTY, basically characters on the screen. Okay. And basically everything we did, he's doing again. But at the beginning, you have to tell it what flavor you want your assembler to be disassembled in. Okay. The default will be gas, which is fine. He does show that later. Okay. And then how it works, and you play with it, and you come down, you get to see where the addresses are. And when you walk through the steps the way he does it, you're actually getting memory locations and the contents of that memory. That's kind of cool. Okay. All right. Now, this is the kind of thing you'll do hands-on, and you're going to forget. But you're going to have this dim recollection that registers and things get moved around in assembler. Okay. And basically walking through this, and then down at the very end, your turn. This will be your homework. Okay. I want you to think back to when we did our C program and we returned to 0, right? Ancient history. Remember that? And we returned some other numbers, didn't we? And Kevin noticed that if we returned a big number, it returns something even funnier. The answer to that question is in here. So you'll find out why big numbers look funny when we return it.
Are you expecting a explanation, or what is
Yeah.
it? That's it?
Comment. You're gonna walk through this, you comment, and you're gonna tell me how you understand it. Think of it as a creative writing exercise. Okay. Is it as you do through it, type in the code, make it work, and explain it to me, how you understand it. You can also say, I'm typing this in and I'm making it work and I have no freaking clue. Well, that's fine too. Okay. Because this stuff doesn't make a lot of sense where most of you are in your programming. Okay. If you do Wireshark and you do some network forensics, some of this stuff starts to make a little more sense because you're down at the bit level. Okay. And that's it. Okay. And here's some more fun stuff in here. Okay. And he's having you just test them. And then he goes into the AT&T syntax. Okay. And you'll do your turn. Okay. Program tells you what to do. These are not difficult. I am not giving you these to overwhelm you. If you walk through the chapter, you're going to be able to do this. Okay. All right. And then it says write 3 assembly language functions that return a character. Each function returns a different character. So we don't have to worry about argv, argc, scand, scanf, none of that stuff. You just hard code and it spits it out. Okay. Same thing with the numbers, integers, a non-zero integer. And if you poke around long enough, you can actually find the answers. And some of you will go do that. Okay. And that's this homework this is going to be the assignment, and then I'll create another one in there that's using the scanf conversion to argv, argc, because argv and argc, every operating system has the idea of argv, argc.
Okay, so you want us to go through the
Chapter.
but for like your turn, like 1 through 5 as well, yeah?
Yeah.
All right.
That's all you're going to do.
Basically, get through the entire chapter.
Yeah, you just write it out and tell me how how it makes sense to you or doesn't. And you will see that when you poke on the machine, you're going to get some different addresses. Maybe. And then again, if they're the same, why are they the same? Okay. All right. And everybody's saying, why do I need to learn this? Let me ask you this. I was talking to Charlie before class. I think I mentioned it in here. No, it was the Tuesday night class, I think, Lenny's class. The teachers on faculty just started screaming out into the void because they got removed from their Canvas shells. All the students were still in their shell. Did anybody see that problem? Was anybody online to have that problem? Well, faculty's running around with the chicken of the head cut off, and they weren't being very kind. And I'm sitting here going, well, I bet you I know what the problem is. Is that Canvas is this big monolith, and it has an API you can write to. If you get the credentials, you can actually do stuff at a low level. Our student accounts, I think it's eLumen, might be Starfish, I don't remember, but it's the record management side of where your records go. Well, they don't talk very well together. And what happened was the APIs, the things that were communicating, the railroad tracks that were connecting those two systems together broke because one of the vendors changed something and didn't tell anybody until there was this train wreck. I can't log in and do my work. How do you think they found the problem? Debuggers, log files, trace reports. That's the stuff you're going to need to know. Okay. Because getting a problem like that is hard to fix. It's also hard to define Because if it's intermittent, it's a tough problem to solve anyway. But if you can duplicate the problem, you can almost always fix it. But in this stack spaced web sphere thing, one's a PHP app and another's a Node.js app. Yeah, you have to have a translator in the middle. And the fellow who's kind of in charge of this, they're actually going to have to write a separate process that does a side load of the app to work around the vendor's crap. Does that sound fun? No. Does it sound complex? Yes. That's the world of where we're in. Layers and layers and layers of software. You got to look at the log files.
I found the vendor, their name is Synergetic, and apparently there's a history of this happening.
Yeah. Who knows what happened? Okay. But that's so be kind to the IT people that are trying to fix this stuff, because oftentimes they're blindsided too. And I'll tell a story that dovetails with Microsoft and what Charlie was talking about before class. I almost lost my job, i.e. fired at Foster Farms, not once but twice, because Microsoft couldn't fix their own crap. But it's still my fault. The first, the one I'll mention is that they were on Windows NT, and for some reason, the people before me had all the AIX Unix boxes print to the Windows NT print subsystem and then to the printer. You're spooling a spooler. Okay. Well, what happened is the update went to Windows NT. Not one single AIX system could print. Well, AIX is my box, my neck, because you can't print invoices. Invoices go with trucks. Trucks can't roll if they don't have invoices, at least back in the day. So, all right, I did some sleuthing. These printers here have a built-in spooler mechanism. And these printers, they had HP and they had other ones, they had little jet boxes. They can handle 2,500 simultaneous print jobs from 2,500 separate hosts at the same time. This little box. That's a lot of hosts. So what I did is I used AIX and their tools, and I just bypassed the Windows stuff directly and went straight to the printer. Okay. Solved the problem, got everything working, everybody was happy. All the way up to the level 3, level 4 engineers in Microsoft said, well, we don't know what's wrong. And I had it all working, so production was back online. And I'm talking to the Windows guys going, this is stupid. Why do you need 3 people to fix one stupid printer? So my way one, eventually I found a contact in IBM who had to deal with this same exact problem. And they told me how to fix it. It was a Windows NT fix that when they rolled out their version of the Windows print spooler that's supposed to talk to AIX, LPD, LPR, it completely hosed it. You just had to roll back the version and it would work. And the reason the Windows guys didn't get upset said, well, it prints from Windows. So, yeah, you will get stories like that, and they will happen to you. Was that my fault that the AIX went down? They couldn't print invoices? No. they rolled out an update to Windows NT and it trashed the print system. Oops. I'm gonna do some magic and figure things out. So. There you go. That's just one story. I've got many more like that. Okay. All right. So we have our meeting today for computer science, and Jonathan will be online, and I'll face it. I'll probably get another camera so we can actually do a little more. And he'll be up here, and hopefully I'll see you guys. Okay. And then I will write up this stuff. So I think when you do chapter 10, and then I will set up the code for you to actually see the before and after of the foo, where it prompts you for an integer versus putting it on the command line. Okay. I'll give you all the code for that so you can assemble it and make it work and use it in the debugger, because that's the goal.
They're gonna be available on Canvas via an assignment or found in the.
It'll be an assignment via Canvas that points to my website. Okay. Because if this keeps happening with Canvas, oh, we're gonna have to upgrade again and migrate off to something else. Well, I still use web 1.0 HTML, brain dead, static websites. Okay. All right. Everybody figured out what we got going, kind of some big spot, and then the make files. We'll figure out the make files. We'll all figure out the make files. And let you know. Anybody a make expert?
I got one working.
Oh, you did. Good.
Yeah, I don't know if it's right, but it works.
Yeah, that's can't argue with success. All right. So on that note, I'm going to stop the share here. And oh, okay.
Yes. No.
Answers to everyone. Okay.
It's Wayland too.
Wayland?
Yeah.
Oh, yeah.
Oh, it's a pain in the butt sometimes. I mean, like, yeah, well, it depends on what you're trying to do. So like, if I want to estimate, but I want to forward Wayland instead of forwarding X, right? That's not fun. But like, it has like an emulator for X servers, so you can do Wayland X.